Hello, everyone. This lesson is on factoring trinomials. Now, if you recall, trinomials have three terms. So we're going to be looking at quadratic trinomials. And basically, quadratic just means it has an x squared term as the leading term. So it's going to be of the form ax to the second power plus bx plus c, where c is some constant. All right, and x is the variable. All right, so what is factoring? Well, in a previous lesson, we did multiplying binomials. Uh, Factoring, you can think of as undoing the multiplication. All right, and hopefully, as we do this lesson, it'll become more and more clear. But we're going to be using something called the slide and divide method. Slide and divide. So, what are we sliding? Well, we're going to take the a term and we're going to multiply it with the c term so that the x squared will be by itself. The a will disappear and we'll multiply it with the c. So our first step is to multiply a and c. All right. This will give you a new equation of x squared plus bx plus ac. All right. There's no more a in front of the x squared. It's been multiplied with the c at the end of the expression. All right, so we're going to take this and multiply it in Desmos. You can also use a handheld calculator if you're proficient. And it's going to graph a picture like, say, we have here on the right. And since it's quadratic, it forms a curved parabola. And it gives us, in this case, two roots. And the root you can think of as the x-intercept, as the zero of the function. All right? So here we have two roots. One is at -3. One is at +4. All right? So you find the roots. And these are basically just the zeros. And what you're going to do is going to change their sign. All right? And then we'll write it in a factored form and divide by a. Now, if that doesn't make sense, just hold on, and hopefully it'll all become clear. But these are the steps to factor and undo a trinomial and separate it into two binomials. So here we have example 1, 2x squared plus 13x plus 15. So we identify our a, b, c. And we're going to slide and divide. We're going to multiply a times c. So 2 times 15 is 30. So our new expression is x squared. See, we moved the a, we moved the 2, plus 13x plus, now it's 30. So I kept the b the same. All right, so the b term is unchanged. The a is gone. And now c changes from 15 to 30. Okay, so now we graph this x squared plus 13x plus 30 into a calculator. I'm going to use Desmos. And here I've typed it in. And remember, you can use the calculator, the keyboard on the lower left to help you write the x squared. You see this, we've got an x, y, a2, b2. Just hit x and then a2 and you're good to go. So I've graphed it, and what are my roots? I have two roots. One is at -3, and one is at -10. So I come back here, my roots are -3, -10, but now we have to change the sign. So our factors are 3 and 10, and we're going to write it in factored form. And this is what I mean by factored form. It's going to be x, and since it was +3, the factor is +3, I write +3, and then x plus 10. So they're positive because we had to change the sign. But if you'll recall, it's called slide and divide. So now we have to go back and divide out that 2 we multiplied. All right. Now we try to reduce where we can. So 3 over 2 is 1.5. But if I hit the fraction button, we see that it's already in reduced form. It's already 3 over 2. So I come back over here. I'm not going to change 3 over 2 because it's reduced as it can. But 10 over 2 will reduce into a nice, clean whole number. Let's see. So I've written out of room. Let me draw an arrow to show that I'm continuing on the right. Now, don't worry about why this trick. I'm going to show you a trick. Don't worry about why it works. Just trust me on this. I'm going to take the 2 here and put him in front of the x because we don't want fractions. We don't want decimals. So it's going to be, oops, let me change the color back. It's going to be 2x plus 3 times x plus, and 10 divided by 2 is 5. So you see I moved that 2 in the denominator in front of the x. And we're done as far as solving the problem, but we have factored it. All right, we have taken the trinomial and reduced it to its binomial factors. Now, how can we prove that we got the right answer? Well, remember what I said, factoring is the reverse of multiplying binomials. So all you have to do to check is just remultiply the binomials. So using double distribution method, I split up the 2x plus 3 and double the x plus 5. This is just what we've done in a previous lesson. And then you distribute. 2x times x is 2x squared. 2 times 5 is 10x plus 3x. And then, of course, 3 plus times 5 is 15. No more multiplying because the parentheses are gone, but we do combine the like terms. 2x squared, 10 plus 3 is 13x. Bada bing, bada boom. We, excuse me, we have our original trinomial. So we know we did it right. Pardon me. So we factored. But we're going to try it again on another problem, another example. Here's my A. Here's my B. Here's my C. So A times C will be 6 times, and careful, negative 10. And that yields negative 60. So we now have the trinomial x squared minus 11x minus 60. Going to Desmos, I pop it in. Now you may have to zoom out, move around, but we get negative 4 is a root and positive 15. So my roots are negative 4, positive 15, but our factors, we have to change the sign. So it's positive 4, negative 15, yielding a factored form of x plus 4, x minus 15. And I haven't given myself enough room to do the division, so I'm going to rewrite it up here. X plus 4, x minus 15. And of course, we multiply by 6, so now we're going to divide by 6. Well, these are not whole numbers, so we're going to try to reduce the fractions. So 15 over 6 is 2.5, but if I hit the fraction button, I get 5 over 2. 4 over 6 is 0.6 repeating, but if I hit the fraction button, I get 2 over 3. Desmos is so handy like that. So x plus 2 over 3, x minus 5 over, was it 5 over 3? 5 over 2, excuse me. Yeah, 15 divided by 3 is 5, 6 divided by 3 is 2. And then we do our little trick where you move it out front, giving us the final factored form, the two binomials, 3x plus 2 and 2x minus 5, which if you remultiplied will give you the original problem and it will be proof that you correctly did it.